Hello again, this is Physics Made Simple, and we are going to be going over the scientific method. Welcome aboard. So pause to success is a rule that I usually follow in my videos, and I used to follow in my classes. Students enjoyed remembering it by pause, which means P is for planning your work, which begins by collecting all the information that you may need for that experiment or that activity that you are working on. A is for taking action, which begins by the experiment itself. Once you're done with that, you go ahead and collect your data, you go ahead and analyze this data, and you are ready for your next step, which is writing down your findings and concluding. This is the easiest way to remember all of your steps in one word. So back to our scientific method, a little bit of background information. What is the scientific method? By definition, it is the process of gaining, organizing, and applying new knowledge on some type of topic that you are focusing on. So in our everyday life, which is not necessarily scientific, think about your morning decision to pick out your outfit. It's a very simple problem that requires planning. Depending on what it is that you have for that specific day. If you have a meeting, you are going to be dressing up and wearing something formal. If you have some exercise outside, outdoors, you're gonna wear an outfit that fits that plan. If, for example, it's very cold and it's a snowy day, you are going to make sure that you are fit for that weather. That being said, it one requires planning. You open your closet, you plan what you want to wear, and you make a decision about one outfit. You go ahead and stand in front of the mirror and put your clothes on, and you look at it. Oh my gosh, I've gained weight, and now it doesn't fit anymore. I have to go back, plan again. What am I gonna wear? What's the occasion? Does this work out? Yes, it works out. Let's go ahead and do the trial, experiment with it. Fits, fine, okay, works for the occasion. What do you do now? You go ahead and go on about your day. Now, of course, this is not scientific, but this is the easiest way to remember what the scientific method is supposed to be in our everyday life. It's basically planning and trying your plan uh, before you go ahead and take action for your plan. So the steps of the scientific method at a glance. Our plan consists of questioning and observation. Uh, you ask yourself the question, what am I looking for? What is it that I am going to be uh, experimenting with to reach what answer? That being said, you are going to come up with something called a hypothesis, and we'll talk a little bit more about this on the next slide. Your research will take most of your time because you need enough information about your topic, and that being said, you go ahead and plan your experiment and you collect all your data. Once you do that, you analyze your data, and from then you decide if you are not going to be retesting, you will be concluding and communicating your information. So again, the following steps are the simplest definitions I can use to help you remember the scientific method. Uh, First, you basically ask the question, then you guess based on your scientific knowledge what you will be doing to what you will be eventually getting to at the end of your testing, which is called a hypothesis. Then you go ahead and do your testing. When you test your guess, you make sure that you identify your variables, which is the independent variable, which is what you don't change. Your dependent variable is what you are measuring, and your control is what you keep constant throughout your testing. Analysis and a conclusion. This is where you basically decide what did I do, and is everything I've done um, leading to a conclusion or not? Should I redo it or not? And you summarize what you've done, and you share and communicate your information. So at a glance, exactly what I just went over in the previous slide. This is the information. If you want to screenshot it, pause it, take a look at it, these are the steps. So as a simple example, let's go ahead and take a look. We are going to plan how we can gain more information about a specific topic. Here's our topic. First, we're going to ask ourselves the question, and we're going to research the information. So here's the question. Does diet soda make more fizz than regular soda? Okay. Um, to do that, you have to go ahead and dig more into what makes the soda fizz. You have to dig more to see is it the sweetener, is it the sugar, is it the carbon dioxide? What are the additives that are added to either one of them? That being said, you're going to go ahead and decide what your hypothesis is. So as you can see here, we've decided that our hypothesis is artificial sweeteners in diet soda will make more fizz than regular soda. Okay, let's go ahead and conduct our experiment. So what will our experiment look like? First of all, we have to identify our variables. The variables, for example, my independent variable is the type of soda, and my dependent variable is the amount or the height of fizz. That's exactly what we will be measuring in order for us to decide uh, which one will fizz more. And since we are measuring the artificial sweetener, we are focusing to compare the height of fizz of diet soda versus the regular soda. What we're going to control and keep all throughout the same throughout the testing is the temperature, volume, and how many Mentos are we going to place into these bottles. Then we're going to collect our data, and once we collect the information, we're going to look at this data and say, okay, did I answer my question? Did I reach a conclusion? Do I need to do further testing? If so, I'll go ahead and go back and test again. If not, then I'm going to go ahead and write my findings, and I am going to conclude or summarize everything I've done. And I'm going to say, okay, I did A, B, C, and the aim was to reach this answer, and I was able to answer it. Or you can say the opposite. The aim was A, B, C, and I did not reach my conclusion, therefore my hypothesis or my testing failed, and I would have to retry. In this section, always use your CER because it is used widely across all sciences. The CER is, first of all, is the claim, which is what you're claiming you are going to do to answer that question. Do you have evidence that this question was answered? So you are going to put all your numbers and all your data and all your pictures and tables that you have collected as evidence, and your reasoning is when you are making sense of this information that you've collected, and you're going to provide it in the reasoning part. Make sure you share your results out, and that is how your information will be communicated and not lost. These are some pictures that I'm providing for you as to when conducting the experiment, and what kind of information will be helpful when you gather your needs. I've shown in the first picture, this is the regular soda, this is the diet soda. In the picture in the middle, it has the temperature, so my control will be the temperature. Everything is happening under the same temperature. The amount of um, Mentos, there's only one Mentos on each tray, and while conducting the experiment, I make sure that I have already identified all these variables. My independent variable is the type of soda. I'm going to be using regular, and I'm going to be using diet. So I'm going to be monitoring the regular, monitoring the diet. And my dependent variable is how much, or this is what I'm testing. This is what I'm looking for, the amount of fizz produced by these two. And like I said, we've already mentioned the control. This is a picture of the data that I've collected. It's always good to remember that the focus of your experiment is one thing. So if I am measuring the amount, that means I am going to be measuring in a specific measurement, which is in here in milliliter. So the diet soda, the first trial was 240 milliliters. That's how much the amount of liquid or of the fizz that was collected after the experiment. The trial 2 was this much. Regular soda, same thing. Trial 1 produced this much and trial 2 produced that much. Now, if I am measuring the height of the fizz, then I am going to have different materials in my materials collected, and in the procedure I'm going to say that I'm going to be using, for example, measuring tape for the height. And that being said, we are going to be using centimeters if it's in centimeters, meters if it's in meters, depending again on how much of the Mentos you have used in your experiment, because of course that's going to make a big difference in the amount of fizz or the height of fizz that will be produced. So again, this is a way of remembering what is needed for your experiment. So now that I have the data of the experiment, do I need to redesign it? Do I need to start from the beginning? Did I reach my goal? With that being said, I need to make sure that if I did change or alter any materials, I need to mention that. If I build things differently, I need to mention that. If I use different sizes, I need to mention that, because yes, some people will go ahead and rebuild and redesign the experiment, make sure they have larger bottles, larger volumes, so that they can ensure that this result is correct. And also, please make sure that you write about or show your images of every single step of your redesigning process, because it's very important also to document this information and provide it with your communication and sharing. And finally, you're going to write your findings. To write your findings, you make sure you answer the question in the writing process, and you make sure you write your conclusion with the CER that I've mentioned. Again, the claim, what you've claimed you are thinking is correct, which is basically your hypothesis. Evidence is everything from the beginning to the end that you have collected to make sure or ensure that your result is correct. Because remember, the scientific method is supposed to be reused and retested by somebody else who decides whether they want to prove you right or prove you wrong. So in order for them to experiment the same exact testing that you've done, they have to have everything. You don't want somebody to go out in public and say, hey, this person has claimed blah 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 and I am proving them wrong blah blah blah, because you've missed on any of the evidence or you did not put any of the evidence in your writing. So make sure every evidence is collected and produced and provided in your writing process. And make sure you also write in your reasoning or conclude that these are my findings, and yes, I was able to answer, or no, I was not able to answer my information. So discuss it in details and write how you or reflect how you feel about the whole process. Last but not least, I want you to go ahead and reflect on your knowledge or what you've learned in this short video. What are the steps of the scientific method? Please remember that first you have to identify your problem, then you have to guess about it using research that you've already done to make that guess or prediction. You go ahead and perform all the experiments you need. If you ended up reaching the result that you were aiming for, great. If not, redesign, restarts if needed, and formulate your rules and communicate your findings. How do I write a hypothesis? This is basically just generally speaking, when you're writing a hypothesis, it's basically a statement saying that if this is correct, then this is correct. If the independent variable change one way or another, then the dependent variable is going to respond this way. And the format is not always necessary to be the same, but basically this is the easiest way to remember. So um, if I test regular Coke versus Diet Coke, then I am going to find out that Diet Coke is going to fizz more due to the presence of sweetener. That being said, thank you very much for listening and tuning in. You have another topic coming up very soon. If you like to join our channel, great. Thanks again and good luck.